Guys, and welcome back to another video on the channel. In today's video we're going to be taking a look at 2022's Math Methods External Exam Question 1 from Paper 1. Now you would have noticed with all the videos on the channel I've been splitting them up into their individual questions as well. Don't worry, this full exam video is still up on YouTube. The link is in the description below. However, I found it'd be a bit more helpful if people only struggle, if you struggle with certain types of questions, you can go to that actual video on the channel rather than going through the entire external exam, but still have the option to pick both, okay? If you need a Math Methods External Exam bundle pack, the link is in the description below. We're only going to be selling a couple downloads this year for it. So if you want to get in quick, head to the link in the description below. It's a pretty hard external exam bundle pack, but it definitely gets you ready, and it comes with full work solutions as well, okay? But otherwise, let's get straight into question 1 here. So, this one here. So, consider the graph f dash of x for a is less than x and b is greater than x. So, over that interval here, okay? So, which of the following statements describes all the local maximum and minima of the graph f of x over a and b? Alright, first of all, let's establish this, okay? A lot of people are going to misread this graph and think that is f dash of x. Not f dash of x. They're going to think this is f of x and then be like, oh yeah, there's a minimum here, etc. And they will probably put c as the answer, okay? This is not the case at all, okay? This is f dash of x that we're looking at here, okay? So f dash of x is the derivative of f of x, okay? So whenever f dash of x is equal to 0, that indicates that there is a stationary point. Okay, a stationary point is a maximum or a minimum, because that is when f dash of x is equal to 0, because the gradient is flat there. Okay, so here what we're looking at between a and b is that there are two places here when the f dash of x is equal to 0, here and here. Now let's understand what we're looking at here, okay? Because we need to work out if it's a max or a min. So, beforehand, the gradient is positive in the yellow section. The gradient is negative in the green section, because if this is the graph of f dash of x, this is when f dash of x is positive, and this is when f dash of x is negative on the axis here. So if it's going from a positive gradient to a negative gradient and it passes through 0, that indicates that it's going to be a maximum, because if we look at a maximum, it goes from a positive gradient to a negative gradient, where the negative gradient is the direction of those lines there, and the positive gradient is the direction of those lines there, which passes through that stationary point. So because of that understanding there, we know there is going to be one local maximum, okay? And if we look here, it's going from a negative gradient to a positive gradient, meaning it draws this picture here, where it goes from a negative gradient, where the tangent lines are facing that way still, to a positive gradient, which is facing that way still, which indicates a local minimum. So here we've got to look for the answer that has, quote unquote, a local minimum and a local maximum, okay? So here, the reason why these ones are incorrect: there isn't just one minimum and one maximum. There is one of each. B, the reason why B is incorrect is because they're saying there's two local maximums. That's incorrect. A lot of people would misread it and think, oh, that's the maximum there. No, it's not, okay? These are the local minimums and maximums. So the correct answer here is A, okay? Now, I'm not sure in the previous video, like the full exam video, I described it like that. However, I'm definitely doing it now here, okay? That's your answer, question 1. If you have any questions about this one here, you need to study concavity of derivatives and just functions in general. If you need a Math Methods exam pack, go to the link in the description below and get your download, okay? But otherwise, I'll see you in the next video. If you have any questions, leave something in the comments as well, okay? But see you in the next video.